The important concept of Poisson ratio. First of all, Poisson ratio is the property of the material, and Poisson ratio is only defined up to elastic limit. So Poisson ratio is only valid in the elastic region. The definition of the Poisson ratio is transverse strain divided by longitudinal strain. Now, transverse strain in the case of rectangle can be epsilon y upon epsilon x or epsilon z upon epsilon x. First of all, the term mu is only defined for direct loading in x direction. So mu is a tool which helps us to identify that if there is a stress in x direction, what effect will it cause in y direction. So there is no definition of mu in triaxial loading. Mu was defined only for uniaxial loading. And suppose, yes, so the first thing is mu is equal to minus ey upon ex, and is it also equal to minus ez upon ex, transverse loading. And ey, you know, delta b upon b and delta l upon l, and this is delta t upon t and delta l upon l. So this was the thing which is defined, and you know there is a minus thing, but we take modulus. Mostly the mu is 0 to 0.5, but in practical cases it is mu. First of all, mu can vary from minus infinity to infinity, but the thing is, for practical engineering purposes, mu is 0 to 0.5, and in more cases it is minus 1 to 0.5 it is defined. But minus we don't use, because minus, there is a material called asbestos, it is minus, but we don't use that material. Remember, mu is a tool which was for defined for an elastic material, and it is only defined for direct load in x direction. So it, with the use of mu, we can find if there is just a triaxial loading, what will be ex. The standard definition of ex is equal to change in length minus upon initial length. Ey is equal to change in breadth upon initial breadth. Ez equal to change in diameter upon initial diameter. अगर स्ट्रेन की वैल्यू नेगेटिव आती है, इसका मतलब द फाइनल dimension is less than the initial dimension. Now I am writing the general expression of delta L. Delta L by L in a body which is facing triaxial loading and also thermal stresses. So delta L by L is equal to strain in x direction is equal to sigma x by E minus mu sigma y by E minus mu sigma, it's sigma x by E plus minus mu sigma y by E plus minus mu sigma z by E. This is due to mechanical effect, and plus in x direction there is a thermal stress which will cause thermal strain, whose value is this. If the thermal temperature is decreasing, T final minus T initial will give the negative value, so overall it will become negative automatically. Plus minus mu alpha B delta T by B plus minus mu alpha T delta T by T. So this is due to thermal effect, and this is due to mechanical effect. So mechanical and thermal do not intertwine in each other and do not interfere in each other. Similarly, you can write the strain in y direction and strain in z direction. The standard definition of strain is change in breadth upon original breadth, change in thickness upon original thickness. This is the standard definition, it does not changes. Remember, there is a strain. Strain means elongation, and elongation, of course, there is a shear strain, and shear strain is change in angle. But as we are dealing here with elongation, if there is a elongation, there must be a normal stress, because only normal stress can cause this. Normal stress can only cause normal strains. And there is a mystery question: what if he says that the material is not isotropic and homogeneous? This means that the value of elasticity for x direction, y direction, and z direction is not same. Then in this case, how will you define the elastic strain, sorry, longitudinal strain, transverse strain, and transverse strain in z direction? How will you define this? I am not sure about this equation. You have to find it. The formula such as Young modulus is equal to stress by strain and modulus of rigidity is equal to shear stress upon shear strain is only valid up to the elastic region, and after elastic region this formula does not have any validity.